I'm going to discuss today some examples related to the lesson conditional statements. Okay, let's start with example number 1. Determine the truth value of the following conditional statements. So you remember statements which are in if-then form are what we call conditional statements, and we are asked here to determine the truth value of these conditional statements. Just some review of the truth table of conditional statements. Remember that the conditional statement given by P implies Q, or if P then Q, has the following truth values. First, if P and Q are both true, we say that P implies Q is true, and when P is true and Q is false, then we have false for P implies Q. And in fact, this is the only instance where your P implies Q is false. Your P is true and your Q is false. But if you have false, true for P and Q respectively, you have true. And if you have false, false, you have false for true for P implies Q. Okay, following this, let's consider example number 1. What is the truth value of this one? This is your P and this is your Q. So if 2 is even, now 2 is even is actually true, right? And 2 is not prime is false. Do you follow? Because the first prime number is actually equal to 2. Okay, so this is true. Well, this one is false. Okay, because 2 is a prime number. So this statement is therefore false, right? Okay. What about this one? If today is Monday, now I'm doing this today, and today is Monday actually. So if today is Monday, this is true. Then yesterday is Sunday, which is also true. Okay. And following our truth table, this statement is true. Actually, even if today, for example, is not Monday, let's say I'm doing this on Tuesday, and then I say if today is Monday, that's already false, right? Yesterday is Sunday is also false, but following our truth table, that's still true. Okay. So the statement is always true regardless of whether today is Monday or today is not Monday. Letter C. If 4 is greater than 3, of course this is true, right? Then 2 plus 1 is equal to 6, which is false. Again, according to the truth table, this statement is false. What about letter D? X less than or equal to 2, then x plus 5 is less than or equal to 7. There's actually no way of knowing whether this statement is true because this is an open sentence, and this one also is an open sentence. So what we can do to determine the truth value of this is to assume that this is true. Suppose this is true, okay? Suppose this is true. Meaning, suppose your x is any number less than or equal to 2, okay? So question is, if this is true, then is this true? Okay, like for example, you have 2 for x, so is 2 plus 5 less than or equal to 7? Or if, for example, your x is equal to 1, is 1 plus 5 less than or equal to 7? So you will notice that if this is true, this is also true. So therefore, this statement is true. Now, you may argue, what if this is false? Well, if this is false, regardless of the truth value of this, the statement is always true, right? Because according to our truth table, when your P is false, automatically you have true for P implies Q. Okay. Second example, write the following in its equivalent disjunctive form. Okay, what do you mean by disjunctive form? From the handout I uploaded, the disjunctive form of P implies Q. We've proven this using truth table. No, this is equivalent to negation of P or Q. So this is what we call the disjunctive form of conditional statement. Disjunctive because we have a disjunction here, right? Okay. So we say write the following in its just equivalent disjunctive form. This is your P and this is your Q. So in disjunctive form, this is the negation of this one, of this P. So you say you get to work on time, or okay, or you are fired, right? Okay, so you negate this one. The negation of this is you get to work on time, or replace this with or you are fired. So that's your disjunctive form. What about this one? If my car is in the repair shop, then I cannot get to class. Again, following that, we have my car is not in the repair shop, or I cannot get to class. Okay, so that's the disjunctive form of this statement. Next example. Okay. Write the following in if P then Q form. Okay, this is actually that part, no, in the handout where the if P then Q has some common forms. Let me show you that part of our handout. Okay, these are some common forms of P implies Q. And for this particular problem, example number 3, it uses every, okay, and this is similar to this one, right? Okay, so every even number is divisible by 2 in if then form. In other words, following that one. Okay, this means that if a number is even, that being your P, okay, then it is divisible by 2, this being your Q. Okay, what about for letter B? It uses here the connective necessary condition. Necessary condition is here. Okay, and look at the normal positioning, no, of P and Q is P first then Q, but here the Q comes first whenever you use the necessary condition. So in other words, this is your P and this must be your Q. Diba? So in if then form, it will be if John is eligible to vote, then he is at least 18 years old. Okay, so let's end here and we'll continue the rest of the examples in the next video.